Good morning, children. Today, we are going to learn about the eye defects. In our previous class, we have learned something about the different parts of eye and how they function and important characteristics of the eye, that is the accommodation of the eye. Today, we are going to see the common scenario that we observe in our elderly people, in our teachers, in our parents, the defect of vision. Before going to that, let us see what topics we are going to cover in this lesson. Yes, this is the part 2, that is the second class of fifth lesson. Mainly, the topics which are going to be covered in our lesson is the main is the defect of vision and the related terms far point and near point. These two terms are very important regarding this defect of vision. In order to learn the defect of eye visions, we have to learn those things, and various types of eye defects like myopia, hypermetropia, and presbyopia. And the most important thing, how they are corrected, how the visionary defects are corrected. All these things will be covered in our lesson. So, dear students, listen carefully. And most important, in examination point of view, you may be asked to draw the array diagrams regarding these eye defects. So pay attention. Let us step into the lesson directly. Before going to learn the eye defect, that is a visionary defect, first of all, let us know what is a vision. The vision is that is the ability of the eye to see the objects is known as a vision. Yes, that we have. In Telugu, మనం ఏమంటామంటే దృష్టి అంటాం. దృష్టి అంటే ఏంటి? మన చుట్టూ ఉన్నటువంటి ప్రపంచాన్ని చూడగలగటం. దట్ ఈస్ మనకున్నటువంటి దృష్టి, కంటి దృష్టి అంటాం. Then what happens? Is it possible to everyone to see the world around us clearly, distinctly? No, no, no. Sometimes your friend, your classmates, they may struggle to see the blackboard correctly. They cannot read the blackboard. They cannot see the objects which are very far away. Of course, they cannot see the hills which are situated away from us. Some of your friends, some of your father, maybe your grandfather, may find it difficult to see the objects clearly, distinctly, which are at near places, sometimes which are at distance places. What happens? With their naked eye, the vision for them becomes blurred. They cannot see the objects clearly. This inability of the eye is called defect of vision. What is that? Defect of vision. Yes, it is also called as eye defect. So, in your as per your curriculum, there are 3 types of defects. Let us know one by one. In normal vision, what happens? Yesterday we have seen here you see the rays reflected from an object enters the eye through the eye lens and converges at retina exactly. On the retina, the image is formed. Retina converts the image into the electric pulses. Then brain perceives it as an object. This is the procedure of vision. This is actually supposed to be happen in a normal, healthy person. This is a vision, what you are seeing on the screen. Now, let us get into the different types, various types of vision, that is defects of vision. In your textbooks, the defects of vision is divided into 3 types actually. That is myopia, or it is also known as short-sightedness. The second one is hypermetropia. It is also known as long-sightedness or far-sightedness. And the third one is presbyopia. Actually, these three are categorized under refractive defects. Mainly, these defects occurs because of the uh, refractive nature of the eye lens fails. So then these three defects occur. Actually, there is one refractive defect, that is astigmatism, that is not given in your textbook. So no need to discuss about it. Now let us learn all these three defects and how they are going to be corrected. The first one, what is it? The myopia. It is also known as nearsightedness, also known as a short-sightedness. The myopia is the technical term, whereas the two terms are usually we use to pronounce. Yes, myopia. What is this defect? Let us know. Let us try to define it. You may have seen some people like me. We used to read the book keeping at some distance, as you do. You people, you can keep the book very near to your eye, you can read it. But for the persons like us, we cannot see the uh, content in the book. For that, we have to keep the book away from our eye. This is a myopia. What is it? It is the defect of vision due to which a person cannot see the distant objects clearly but can see the nearby objects clearly and distinctly. Yes, what is it? It is a myopia or nearsightedness or short sightedness. Okay, so nearby objects can be seen clearly but not the far away objects. What may be the reason? Now, let us find out the reasons for this myopia. See, as I told you earlier, these three defects comes under refractive visionary defects. So the reason may be high converging power of the eye lens. So if the eye lens converges very high with very high power, this myopia occurs. And the second one is eyeball. Eyeball being elongated, eyeball being too long, then what happens? In these cases, being the converging power of eye lens is very high and the eyeball being too long, the image is of a long distanced objects formed in front of the retina. Instead of projecting on the retina, the image is formed exactly some millimeters in front of the retina. Then the vision becomes blurred. The person suffering from myopia cannot see the distant objects clearly, but he can see the objects which are uh, kept at nearby distances. In this case, the image is formed, the image from a long distance objects formed exactly rightly in front of the retina. Now let us see with an example with a animation. See, in order to learn about the myopia, we have to learn some important definition. That is the far point. What is this far point? In the definition of myopia, I have told you the person with myopia can see the nearby objects but not see the distant objects. The objects which are at infinity distance, he cannot see. But up to some extent, beyond the least distance of distinct vision, he can see the objects clearly. Beyond that certain point, he cannot see the objects clearly. That point is known as a far point. Now let us try to define the far point. Sorry. The point of maximum distance at which the eye lens can form an image on the retina is called as a far point. This is denoted by M. In the picture, this is the L. What is it? L denotes the least distance of distinct vision. It is about 25 centimeters for a normal healthy person. So myopic person, the person with myopia can see an object which is kept just a few centimeters away from the least distance of distinct vision. Let us say some 50 centimeters, like 40 centimeters. Beyond that, he cannot see. Beyond that point, the person is not able to see the objects clearly. So that point is known as M. For example, if I keep an object, for example, here, where the cursor is seen here, I am moving this cursor. For example, a object is kept here. Then the person with myopia cannot see that object because far point being M, it is here. Up to this extent only, the person can see the objects clearly and distinctly without any strain. So this is the defect and this is the far point. Now let us see the ray diagram for the ray diagram depicting the myopia. If the object is at far point, he can see the objects clearly. The problem arises only the object is at infinity. Now see the rays. These rays are coming from a object which is kept at infinity distance. The parallel is coming from infinity distanced object falls on the eye lens. They are converging rightly in front of, let me clear it. 1 minute. Yes. See what is happening in myopic eye. The rays coming from a object which is kept at infinity distance converging rightly in front of the retina, not on the retina. In this case, the image becomes blurred. You cannot distinguish the objects clearly. Yes, this is the defect. See, here we can see the first case. The rays are coming from a object which is kept at distance, infinity distance. They are converging in front of the retina. If any object kept beyond M, that is the far point, also happening the same thing. They are converging in front of the retina. In this case also, the person cannot see the objects clearly. But when the object is kept exactly at the far point, at M, then the person can see the object clearly. Now, let us try to explore the possible ways to correct the myopia. How the myopia is corrected? Yes, for any problem there is a solution. Like that, myopia also can be corrected by using lenses. Yes, myopia is corrected by using the spectacles fitted with concave lenses, diverging lenses. Yes, the purpose of using concave lens, why we are using concave lens in the case of correction of myopia? Why not convex lens? Because by using the concave lens, we are decreasing the converging power of the eye lens so that The rays from infinity distance forms an image on the retina correctly. With the eye problem, what we do? We consult a doctor. The doctor first investigates your problem with the help of these lenses. You will find out which problem do you have really. Then you will find out which lens to be used. Yes. Now let us see the ray diagram for the correction of the myopia. In your exams, so many times the question is repeated. So students, observe carefully. In order to rectify this defect, the glasses with the for this correction of myopia, to diverge the refracted rays in the eye, the spectacles with concave, it is not mirror, actually it is written mirror, it is lens. Lens is used. See what happens in this case. It is very important, pay attention. See, these rays are coming from an object which is kept at infinity distance. They are coming parallel like this. Yes, in this case, we are using a concave lens. What happens? The object distance is infinity. In this case, the virtual image is formed exactly at the far point M, because the myopic eye, if any object kept at M, can be seen. If not, for example, if any object kept beyond this M, he cannot see. The eye cannot form an image. So, to correct that defect, we are using concave lens. This concave lens, what happens? What makes it? It makes an virtual image of the object exactly at M. Now, for this eye lens, the object is at M. If the object is at M, it happily and without any strain, it can form the image on the retina. In this way, the myopia is corrected by using a concave lens. While using the concave lens, the virtual image is formed at far point. So these dotted rays are showing the virtual image is formed at M. This virtual image is the image for the eye lens. Then it comfortably forms the image on the retina. So in this way, we can correct the myopia. Now, let us see, let us get on to the second defect of vision, that is hypermetropia. This hypermetropia, also known as long-sightedness or far-sightedness. Now let us see, what is it? Now let us see the definition. It is the defect of vision due to which a person cannot see the nearby object clearly, but can see the far away objects clearly. Yes, vice versa of the myopia. In myopia, he can only see the near objects, but not the distant objects. But in case of hypermetropia, he can see the nearby object, far away objects, but not the nearby objects. This occurs age-old people. Myopia occurs that can be seen in children like you. So be careful. Now let us find out the causes. Why this hypermetropia occurs? Because low converging power of the eye lens. That is the first reason. And the second reason is eyeball being very small. That is very short. In this case, where the image is formed. In that case, in myopia, the image is formed rightly in front of the retina. In this case, the image is formed exactly behind the retina. Yes. See, in this case, like for point, we have to define the near point. What is it? The near point is related to hypermetropia. The point of minimum distance at which the eye lens can form an image on the retina is called near point. This is denoted by X. See, this is the least distance of distinct vision. Let us suppose this is the far point. This is the near point. That means behind this, up to this, for example, an object is kept at L. The person with this defect cannot see. The minimum distance at which the object must be kept for an hypermetropic eye is near point, that is X. Within the distance, you only can see the objects clearly. So for the persons having this defect, the least distance of distinct vision may be greater than 25 centimeters. Yes. Beyond that, for example, the object is kept at M, the object is kept at infinity, they can see comfortably. But if the distance is less than the near point, the persons with this defect cannot see the objects clearly. Yes. Now let us see a GIF. Yes. The reflector rays coming from an object are forming the image beyond the retina. In this case, the image becomes blurred. Yes. This is the ray diagram showing us the hypermetropia. This is nearsightedness. Both the defects are shown. This is farsightedness. You can distinguish between these two defects. How this hypermetropia is corrected? Hypermetropia is corrected with the help of a convex lens, converging lens. Yes, by with the help of a converging lens, that is a convex lens, we can correct the hypermetropia. Now let us try to step into the third defect, that is the presbyopia. This presbyopia is related to the old age people actually. As you know, eye has the wonderful nature, that is the accommodation power. Eye lens, with the help of ciliary muscles, they vary the focal length. With the help of this nature, that is accommodation, we can see the nearby objects as well as the objects which are at infinity distance. We can see the stars also clearly. We can see the the pictures in the book clearly. But in the case of a person with presbyopia, that is old age persons, the ciliary muscles becomes failure. That is, they become unable to adjust the focal length of the eye lens. In this case, the person cannot see the nearby objects as well as the distant objects clearly. That means presbyopia can be defined as the combination of myopia and hypermetropia. Myopia and hypermetropia. In this case, a reason maybe ciliary muscles becomes very weak and they lost their ability of accommodation. The eye lens becomes inflexible. How to correct it? For the correction of the presbyopia, we have to use spectacles fitted with bifocal lenses. Bifocal lens means convex lens as well as concave lens. See, age-old persons, they wear the spectacles like this. The upper position is a concave lens. This is a concave lens fitted. This is convex lens fitted. For reading purpose, to see the objects, nearby objects, it is useful. To see the distant objects, this is useful. It is concave lens fitted, it is convex lens fitted. So we have to use bifocal lenses. The spectacles with bifocal lens can be used in the case of presbyopia. Presbyopia is a defect of age-old persons. Now, the last one, what the power of glass. What is it? How it is defined? As I told you, to correct the defects of vision, we have to use a suitable lenses. For myopia, it is concave lens. For hypermetropia, it is convex lens. And for presbyopia, both. Now, what is the power? The power is denoted by the P. P is defined as 1 by F. F is the focal length of the lens that is used to correct the eye defect. And the F value is taken in meters. So the power of glass is defined as P is equal to 1 by F. This is measured in the units of diopters. Yes, it is denoted by D. If the doctor prescribes like 1.5D plus 1.5D, what does it indicate? The positive sign indicates that is convex lens to be used. That means what? Convex lens, when we use the convex lens, in the case of hypermetropia, we use the convex lens. So if in prescription a doctor refers, for example, 1.5D plus or 2D plus, like that, that means the person is having hypermetropia. For correction, the lens to be used is 2 diopters, 2D, like that. If the P is negative, what does it indicate? It indicates for correction concave lens to be used. That means the person is having myopia or short-sightedness. Now let us see a video. So far we have discussed about 3 types of defects and ray diagrams and how to correct them. Now let us see a video. You will clearly understand.
We have got 2 eyes to see the wonderful and beautiful world. So, we should always take care of our eyes. Any problem to the eye will cause a defect in the eye. Let us discuss some of the defects of the eye and ways to correct them. Tony and his friends were walking in a market street while Tony points to a distant restaurant. Tony is able to read all the signboards, while his friend is able to read the nearby signboard, but not the name of the distant restaurant. The ability to see the near objects clearly, but not the far objects, is called short-sightedness. The technical term for it is myopia. image of the nearby object is formed on the retina. The image of a distant object is not formed in front of the retina, but in front of it. Myopia may arise owing to excessive curvature of the lens of the eye, or elongation of the eyeball. Myopia can be corrected by using a concave lens of suitable focal length. A concave lens of suitable focal length will bring the image back onto the retina, and thus the defect is corrected. If this is what a student sitting on back bench sees, what kind of defects does he have? What must he do to correct it? Tony was able to read all the signboards, while his other friend was able to read the name of the distant restaurant, but cannot read the name on the nearby signboard. The ability to see distant objects clearly, but not the nearby objects, is called long-sightedness. The technical term is hypermetropia. The image of a distant object is formed on the retina. The image of a distant object is not formed in front of the retina, but behind it. Hypermetropia may arise because the focal length of the eye lens is too long, or the eyeball becomes too small. Hypermetropia can be corrected by using a convex lens of suitable focal length. A convex lens of suitable focal length will bring the image back onto the retina and thus correct the defect. How far can an eagle see? A lot further than a human eye can see. That's why when someone says, "You must have eagle eyes," they mean you can see a really long way. The power of the eyes usually decreases with aging. Difficulty in seeing nearby objects clearly and also distant objects distinctly is called presbyopia. This arises owing to the weakening of ciliary muscles and diminishing and hypermetropia. Focal or multifocal or varifocal lenses. A bifocal lens consists of a concave lens in the upper part and a convex lens in the lower part. Mirror to see both nearby and
Now, you have seen a video clearly showing us the various eye defects and corrections. Here, I'm going to give you a worksheet. See, try to solve this worksheet. If not possible, consult your teacher. So far, we have discussed about the power of the lens, which is used to correct the eye defect. This is defined as P is equal to 1 by F. F is taken in meters. If it is F is given in centimeters, the formula becomes like this: P is equal to 100 by F. For example, the doctor prescribed the lens with the power P is equal to 2.5D. It is minus 2 point like this. What does it indicate? So in our formula, P is equal to 1 by F. Then F is equal to 1 by P. Substituting the P value 1 by 2.5, it is minus, it becomes 10 by 25. This is equal to 0.4 meters. That is, F we got is 0.5 meters or 40 centimeters. F is equal to minus 40. Yes. What does it indicate? We don't know about the type of eye defection, but doctor prescribed in the prescription, he has written just you use PE, the power of the lens minus 2.5D. That means what? The minus indicates always the concave lens. Let me zoom it. Yes, is it visible now? I think so. Yes, the minus indicates the concave lens. So the doctor referred a concave lens means the person is having myopia. To correct the myopia, he has suggested a lens with 40 centimeter focal length. Like that, you will be asked questions in the examination. So pay attention. Okay, bye for now. Revise yourself. Consult your physical science teacher for your queries. Thank you very much.